Databases are essential tools for data analysts. I use them constantly. Just about all of the data I access is stored within databases. Databases store and organize data, making it much easier for data analysts to manage and access information. They help us get insights faster, make data-driven decisions, and solve problems. You've already heard a bit about what databases are and how they're used by data analysts. Now, let's learn more about database features and components. As you've learned, a database is a collection of data stored in a computer system. Here's a simple database structure. It contains tables with information from a car manufacturer. The top level includes car dealerships, product details, and repair parts. Then, if you drill down to the next level by selecting one of those tables, you'll find more specific details about each item. This is called a relational database. A relational database is a database that contains a series of tables that can be connected to form relationships. For two tables to have a relationship, one or more of the same fields must exist inside both tables. For example, here, branch ID exists in this table and this one. If a field exists within both tables, we can use it to connect the tables together. Certain fields can also be referred to as a primary key. A primary key is an identifier that references a column in which each value is unique. So in our car manufacturer example, we can see that branch ID is the primary key in the dealership table, VIN is the primary key in the product details table, and part ID is the primary key in the repair parts table. Primary keys are unique and can only exist once within a given table. There's also foreign keys. A foreign key is a field within a table that's a primary key in another table. So in our example, the branch ID is the foreign key in the dealership table, and the VIN is the foreign key in the repair parts table. As you can see, a table can only have one primary key, but it can have multiple foreign keys. Relational databases are great for keeping data consistent, no matter where it's accessed. Mobile banking is an interesting example of this. Let's say you deposit a check into your bank account using your mobile banking app. Then you check your account balance on your computer. The database relationship makes sure that the deposit shows up immediately on both platforms. Or let's say you work on a team of data analysts located in different offices. Relational databases make sure everyone's looking at the exact same data and can collaborate using a single set of accurate information. Now let's explore some different types of relational databases. First, a normalized database is a database in which only related data is stored in each table. The main idea behind database normalization is that a table should be about a specific topic and only include supporting related data. This is important because it minimizes the chances of having redundancies. A redundancy occurs when the same piece of data is stored in two or more separate places. Redundancies waste time and space in your database. For example, if you needed to change a piece of data in a database with redundancies, you'd have to make the same update in every place where the data exists. That would take a lot of time and could easily lead to typos or other errors. Next up, we have schemas. A schema is a way of describing the way something is organized. You can think about data schemas like blueprints of how the database is constructed. Schemas are useful when you're learning about a new dataset or designing a relational database. You'll learn more about different types of schemas in an upcoming reading. All right, you've learned a lot about databases and how data analysts use them to gain important insights every day. Soon you'll begin practicing how to access and analyze data from actual databases. That will be a great opportunity to improve your understanding of database organization, the benefits of each method, and how you might use databases in your future analytics career. Now that you understand the different ways to organize data in a database, let's talk about how you can describe that data. In this video, we'll start exploring metadata, which is a very important aspect of database management. Metadata is kind of an abstract concept, though. So let's kick things off with a simple, everyday example. Did you know that every time a photo is taken with a smartphone, data is automatically collected and stored within that photo? Take a look. Choose any photo on your computer. Here's a cute shot of my friend's dogs, Rudy and Matilda. On your photo, right-click on Get Info or Properties. This will give you the photo's metadata, which may tell you the type of file it is, the date and time it was taken, the geolocation or where it was taken, what kind of device was used to take the photo, and much more. Pretty amazing, right? Here's another example. Every time you send or receive an email, metadata is sent right along with that message. You can find it by clicking on Show Original or View Message Details. An email message's metadata includes its subject, who it's from, who it's to, and the date and time it was sent. The metadata even knows how quickly it was delivered after the sender pressed send. Okay, so metadata is information that's used to describe the data that's contained in something, like a photo or an email. Keep in mind that metadata is not the data itself. Instead, it's data about the data. In data analytics, metadata helps data analysts interpret the contents of the data within a database. That's why metadata is so important when working with databases. It tells an analyst what the data is all about. That makes it possible to put the data to work solving problems and making data-driven decisions. As a data analyst, there are 3 common types of metadata that you'll come across: descriptive, structural, and administrative. Descriptive metadata is metadata that describes a piece of data and can be used to identify it at a later point in time. For instance, the descriptive metadata of a book in a library would include the code you see on its spine, known as a Unique International Standard Book Number, also called the ISBN. It would also include the book's author and title. Next is structural metadata, which is metadata that indicates how a piece of data is organized and whether it's part of one or more than one data collection. Let's head back to the library. An example of structural data would be how the pages of a book are put together to create different chapters. It's important to note that structural metadata also keeps track of the relationship between 2 things. For example, it can show us that the digital document of a book manuscript was actually the original version of a now printed book. Finally, we have administrative metadata. Administrative metadata is metadata that indicates the technical source of a digital asset. When we looked at the metadata inside the photo, that was administrative metadata. It showed you the type of file it was, the date and time it was taken, and much more. Here's one final thought to help you understand metadata. If you're on your way to the library to pick out a book, you could research a book's title, author, length, and number of chapters. That's all metadata, and it can tell you a lot about the book. But you have to actually read the book to know what it's all about. Likewise, you can read about data analytics, but you have to take this course to earn the Google Data Analytics certificate. So keep moving forward to gain that new perspective. Now that you know what metadata is, it's time to explore why data analysts use it. You already know that data needs to be identified and described before it can help you solve a problem or make an effective business decision. Putting data into context is probably the most valuable thing that metadata does. But there are still many more benefits of using metadata. Here's one. Metadata creates a single source of truth by keeping things consistent and uniform. We data analysts love consistency, so we always aim for this kind of uniformity in our data and our databases. After all, data that's uniform can be organized, classified, stored, accessed, and used effectively. Plus, when a database is consistent, it's so much easier to discover relationships between the data inside it and the data elsewhere. Metadata also makes data more reliable by making sure it's accurate, precise, relevant, and timely. This also makes it easier for data analysts to identify the root causes of any problems that might pop up. The bottom line is, when the data we work with is high quality, it makes things easier and improves our results. One of the ways data analysts make sure their data is consistent and reliable is by using something called a metadata repository. A metadata repository is a database specifically created to store metadata. Metadata repositories can be stored in a physical location or they can be virtual, like data that exists in the cloud. These repositories describe where metadata came from, keep it in an accessible form so it can be used quickly and easily, and keeps it in a common structure for everyone who may need to use it. Metadata repositories make it easier and faster to bring together multiple sources for data analysis. They do this by describing the state and location of the metadata, the structure of the tables inside, and how data flows through the repository. They even keep track of who accesses the metadata and when. Here's a real-world example. As a healthcare analyst at Google, I use second and third-party data. As you learn, second-party data is data that's collected by a group directly from its audience and then sold. And third-party data comes from outside sources, which are not the original collectors of that data. They get it from websites or programs that pull the data from the various platforms where it was originally generated. It's a bit complex, but the main thing to remember is that third-party data doesn't come from inside your own business. So if my team needs to work with data that wasn't created at Google, that means we sometimes don't know very much about its quality and credibility. But we need to be certain that our data can be trusted and was collected responsibly. After all, if the data is unreliable, our results can be unreliable too. That's why understanding the metadata of the external database is so important. It lets us confirm that the data is clean, accurate, relevant, and timely. This is particularly important if the data comes from another organization. One other important step when working with external data is confirming that we're allowed to use it. We'll often reach out to the owner to make sure we can access or purchase it. So to sum up, metadata repositories are useful for all these reasons. Plus, they help ensure that my team is pulling the right content for the particular project and using it appropriately. We can confirm this because the metadata clearly describes how and when the data was collected, how it's organized, and much more. Soon you'll learn even more about using metadata in data analytics. And if you're finding metadata particularly fascinating, you'll discover some really exciting career choices that focus on metadata. Stay tuned. Metadata and metadata repositories are very powerful tools in the data analyst toolbox. As we discussed previously, data analysts use them to create a single source of truth, keep data consistent and uniform, and ensure that the data we work with is accurate, precise, relevant, and timely. These tools also make it easier to access and use data by standardizing our processes. In this video, we'll explore more components of metadata and learn how metadata analysts work to keep things organized. We know that the amount of data out there continues to grow, but lots of businesses just aren't using their data. Sometimes they don't know what they have. Sometimes they can't find it. Or sometimes a business just doesn't trust it. Especially in bigger companies, data can span numerous different processes and systems. And pulling together data from so many places can be a big challenge. For example, let's say a company starts out with a traditional data storage system in its offices. But then, as the amount of data it owns continues to expand, cloud storage is needed too. Plus, this company could also be accessing and using second or third-party data from a partner organization. Each of these systems has its own rules and requirements, so each organizes the data in a completely different way, adding even more complexity. It's no wonder so many organizations struggle to find the right data at the right moment. On the other hand, metadata is stored in a single, central location and gives the company standardized information about all of its data. This is done in two ways. First, metadata includes information about where each system is located and where the datasets are located within those systems. Second, the metadata describes how all of the data is connected between the various systems. Another important aspect of metadata is something called data governance. Data governance is a process to ensure the formal management of a company's data assets. This gives an organization better control of their data and helps a company manage issues related to data security and privacy, integrity, usability, and internal and external data flows. It's important to note that data governance is about more than just standardizing terminology and procedures. It's about the roles and responsibilities of the people who work with the metadata every day. These are metadata specialists, and they organize and maintain company data, ensuring that it's of the highest possible quality. These people create basic metadata identification and discovery information, describe the way different datasets work together, and explain the many different types of data resources. Metadata specialists also create very important standards that everyone follows and the models used to organize the data. And there's one thing they all have in common. Whether they work at a tech company, a nonprofit association, or a financial institution, metadata analysts are great team players. They're passionate about making data accessible by sharing with colleagues and other stakeholders. So if you're looking for a role that encourages you to explore all the data that the digital world has to offer, following the path to becoming a metadata analyst may be the right choice for you. But either way, businesses of all kinds face market trends and competition, and they need to understand why one process works while another doesn't. Data analytics allows them to answer key questions and keep improving. There's all kinds of data out there, and it's important to know how to access it. Earlier, you learned that there are two basic types of data used by data analysts: internal and external. Internal data is data that lives within a company's own systems. It's typically also generated from within the company. You may also hear internal data described as primary data. External data is data that lives and is generated outside an organization. It can come from a variety of places, including other businesses, government sources, the media, professional associations, schools, and more. External data is sometimes called secondary data. Gathering internal data can be complicated. Depending on your data analytics project, you might need data from lots of different sources and departments, including sales, marketing, customer relationship management, finance, human resources, and even the data archives. But the effort is worth it. Internal data has plenty of advantages for a business. It provides information that's relevant to problems you're trying to solve, and it's free to access because the company already owns it. With internal data, analysts can work on all sorts of data projects without ever looking beyond their own walls. But sometimes internal data doesn't give you the full picture. In those cases, data analysts can turn to external data and apply that information to their analysis. For instance, as healthcare analysts, we often partner with other healthcare organizations or nonprofits and use their data to create deeper analyses and add some more industry-level perspective. In an earlier video, you learned that openness has created a lot of data for analysts to use, largely through open data initiatives. As a reminder, openness or open data refers to the free access, usage, and sharing of data. For example, the United States government makes hundreds of thousands of datasets available to the public on data.gov. These datasets contain information on weather patterns, educational progress, crime rates, transportation, and much more. There are lots of reasons for these open data initiatives. One is to make government activities more transparent, like letting the public see where money is spent. It also helps educate citizens about voting and local issues. Open data also improves public service by giving people ways to be a part of public planning or provide feedback to the government. And finally, open data leads to innovation and economic growth by helping people and companies better understand their markets. Google actually hosts lots of public databases with information on science, transportation, economics, climate, and more. So as an example, a bike-sharing company could use traffic data from within our public transportation database to see where the roads are busiest, then choose those locations for their bikes in order to reduce cars on the road and give people another transportation option. So now you're familiar with internal and external data and how you can access both. Coming up, we'll learn how to import all the data you collect from different sources into a spreadsheet. At this point, you've learned all about internal and external data and how to prepare it for use. Now we'll go through the process of actually importing data from different sources. Sometimes you'll want to upload a spreadsheet from your files, such as a CSV file. CSV stands for comma-separated values. A CSV file saves data in a table format. Now let's bring that file into a fresh spreadsheet. We'll start by selecting a file, then import. Then we'll choose to upload a file. Navigate to it, open it, and insert it as a new sheet. CSV files use plain text and they're delineated by characters, so each column or field is clearly distinct from another when importing. As you learned, CSVs are comma-separated, and usually the spreadsheet app will auto-detect those separations, but sometimes you might need to indicate that the separator is another character or a space by selecting the different options in this window. Also, if you are planning to work with the dataset, you would usually convert to text, numbers, or other options here, but plain text is okay for reporting purposes, so we can leave those fields alone. Finally, select Import Data. Now our CSV file is ready to work with in our spreadsheet. I spend most of my time at work analyzing spreadsheets full of healthcare information. I typically start by looking at a larger dataset, then I pull a subset of it into a spreadsheet so I can work with it. Maybe I want to analyze year-over-year growth in user demand on Google Search for certain healthcare services like telemedicine. Or maybe I want to look at datasets from external healthcare organizations or agencies for more insight into this trend. For example, with telemedicine, maybe I'll look at a spreadsheet that lists telemedicine providers. There are so many ways spreadsheets can help you find the insights you need. One source I use a lot is the World Health Organization's data repository. This is a place where anybody can access open source data. As you can see, there's tons of data available. You can search by theme, category, indicator, and country. You can also access World Health Organization metadata if you want to learn more about the data in the repository. For our example, we'll look at medical doctors by country and year. This information would be useful for a data analysis project looking into how many doctors are available to treat patients within a certain population, compared to other populations. To get this data, we'll start on this webpage, which contains the dataset we want. Then we'll download the data as a CSV file. Then open a new spreadsheet and import the file by selecting File, Import. Next, upload your file and select Import Data. After reviewing the data to make sure it looks clean, we can title it and begin our work. I know this is a lot of information to take in, but you'll get much more comfortable with this the more you practice. Coming up, we'll learn how to sort and filter your data to focus on the information relevant to you. Having lots of data can make it difficult to quickly find and analyze the information you need. No two analytics projects are the same. Often, data analysts process, view, and use data very differently, even if it comes from the exact same source. Here's an example. Check out this spreadsheet that shows a company's sales reps and where they work. Different data analysts might want different information from this spreadsheet, and that's where sorting and filtering comes in. Sorting and filtering the data in a spreadsheet helps us customize the way data is presented. They can also organize data so analysts can zoom in on the pieces that matter. Think of it like a magnifying glass for our data. Let's begin with sorting. Sorting involves arranging data into a meaningful order to make it easier to understand, analyze, and visualize. Data can be sorted in ascending or descending order, and alphabetically or numerically. Sorting can be done across all of a spreadsheet or just in a single column or table. You can also sort by multiple variables. For instance, if our dataset contains both city and state fields, we can sort first by city and then by state. Anytime you're sorting data, it's always a good idea to freeze the header row first. To do this, we'll highlight the row. Then from the View menu, choose Freeze and One Row. This locks the row in place. Now, when we scroll down the sheet, the header row stays visible so we know the category of each column. Looks good to me. Now let's sort the entire spreadsheet. We'll sort by city first. To do this, select the city column. Then use the drop-down arrow to sort the sheet. Select A to Z. This will sort all of the columns from A to Z by row, with the selected column being the primary sort criteria. The cities are now sorted alphabetically, and they're still grouped with the corresponding states, sales reps, and auto parts. The details across each row are automatically kept together when sorting a particular section, as you can see here. Multiple criteria sorting is another very useful data analysis tool. For instance, let's say we want to see a list of sales reps by the cities and states in which they work. First, we select the entire dataset. Then choose Data and Sort Range. In the dialog box, make sure that Data has header row is highlighted. That way, row A, city, states, sales rep, and auto parts, won't be part of the sort. Then in the Sort By drop-down menu, select State and the sort order A to Z. Now add another sort column. In the Then By drop-down, select City and the sort order A to Z. Finally, select Sort. Now we can search the data to easily find a sales rep who works in a particular state and city. Sorting is useful when you want to look at everything in a spreadsheet in alphabetical or numerical order, but sometimes data analysts want to isolate a particular piece of information. To do this, they use a filter. Filtering means showing only the data that meets a specific criteria while hiding the rest. A filter simplifies a spreadsheet by only showing us the information we need. For example, we could add a filter to see only the sales reps who work with a particular product. To do this, we first select Data and create a filter. Choose the column with the data we need, in this case, auto parts. Filter buttons will appear in the corner of each column header. To filter our spreadsheet by auto part, click the button in the auto parts header. In this example, let's say we want to only see sales reps who work with rims. Remove the check marks from the categories we don't want to see, which is everything except for rims. Then select OK. The filter temporarily hides anything that doesn't meet the condition, but note that even though they aren't visible, they're still there. When it's time to view the entire area spreadsheet again, simply turn off the filter. You've learned how sorting and filtering data in spreadsheets helps data analysts customize the information. Customizing data makes it more meaningful and easier to understand, analyze, and visualize. You also discovered that some spreadsheets can be extremely long and complex, so knowing how to zero in on the exact data you need while setting aside the rest helps you focus on your analysis. This is also true for databases. Sometimes a dataset is too large to download, or it won't fit in a spreadsheet. So a data analyst will use SQL to create a query to view the specific data that they want from within the larger set. We've learned that a database is a collection of data stored in a computer system, and that SQL stands for Structured Query Language. Data analysts use query languages to communicate with the database. In an earlier video, you also learned that a relational database contains a series of tables that can be connected to form relationships. These relationships are represented by primary and foreign keys. Data analysts write queries in order to get data from these tables. Let's see how this works. We'll start with our table viewer. Here we can see what public datasets are available. We'll scroll through the data before we start using it to get a feel for what it's all about and to make sure it's clean. Some table viewers let you preview a few rows before even writing a query. This is helpful if you want to take a quick look to be sure the dataset will be right for your project. To show you how this works, let's check out a sample dataset. This one shows how much sunlight hits rooftops in a year. This would be very useful for a data analyst working on a solar energy project, for example. We'll start by previewing the dataset. Click on it like this. Then we'll select a subset of this data where we find regions, states, yearly sunlight, and more. Now to see the entire dataset, Let's write a query. The first step is finding out the complete correct name of the dataset. To do this, select the dataset, solar potential by postal code, and select Query Table. The name of the dataset is shown inside the two backticks. This is to help us read the query more easily. We can also remove the backticks in this case, and our query would still run. The words you see before the dot represent the database name, and the words after the dot represent the table name. Let's select and copy the dataset name now, because we'll need it in a second. Now we'll click on the plus sign to compose a new query. Most queries begin with the word select. Then we add a space. Because we want to see the entire dataset, we'll put an asterisk next. The asterisk says we want to include all columns. This is a great shortcut because without it, we'd have to type in every single field name. Next, we'll press return and type from. From does just what it sounds like. It indicates where the data is coming from. After that, we'll add another space. Now we paste in the name of the dataset that we copied earlier. And finally, run the query. Now we can carefully inspect the dataset before we begin working with it. One important thing to keep in mind, SQL queries can be written in a lot of different ways, but still provide the same results. For example, we could have written this query as one long line of instructions, like this. And we'd still get the same results. The additional lines and spaces don't impact the query's outcome, but they keep your query organized and easier to read for yourself and others. Now, if the project doesn't require all of these fields, we can use SQL to view a particular piece or pieces of data. To do this, we specify a certain column name in the query. For example, maybe we only want to see data from Pennsylvania. So we'd begin our query the same way we just learned. Select, space, add an asterisk. Then, from our solar potential database. But this time, we'll add where. Where also does exactly what it sounds like. It tells the database where to look for information. In this case, the state name column. So add a space and state_name, the name of the column. Now, because we only want to see data from Pennsylvania, we add an equal sign and the word Pennsylvania with single quotes around it. In SQL, single quotes indicate the beginning and ending of a string. Finally, we run the query. Now we can review the data on solar potential for only Pennsylvania. Now we've got the data we want, and we're ready to start putting it to work, which we'll cover later on. But for now, let's celebrate finishing another module. You've covered a lot of complex and highly technical information. As you keep practicing, though, things will start to feel a lot more natural. For now, take a moment to sit back and think about all you've learned. You discovered metadata and how it keeps data organized by describing what that data is all about. You've seen how internal and external data are accessed and how data analysts use them to find compelling insights to solve business problems. And you can sort and filter your data to really pinpoint the information you need. Finally, you just learned about queries, and you even practiced writing some.
Congratulations on finishing this video from the Google Data Analytics Certificate. Access the full experience, including job search help, and start to earn the official certificate by clicking the icon or the link in the description. Watch the next video in the course by clicking here, and subscribe to our channel for more from upcoming Google Career certificates.